An official welcome to the SGA meetup where experts discuss energy efficiency. Today we will talk about energy saving plugin for Unity and best practices like how you save energy based on Tiny Bookstore. We have an hour together, so let's try to have fun and learn something. The first presentation will be done by Oliver, and he will talk about the power saving plugin which he developed. After that, we will dive into the best practices of the Tiny Bookstore by David Zapfe-Wildemann, who is the founder of neoludic games. And after that, we will have like 30 minutes to basically discuss the best practices and what developers can do. I'm Maria Wagner. I'm the managing director of the Sustainable Games Alliance, and we do this kind of meetups quite often. Our mission is to basically decarbonize the games industry and to make it as easy as possible for game developers to be resource efficient, also energy efficient, because like, of course, if you have energy efficient games, it's good for your performance, for your players, but it also helps to, reduce emissions. These are our members. They did not pay me to say that, but I'm highlighting them because I'm really grateful. We would not be able to do the work we're doing without them. So these are all the companies which are supporting the work we're doing. We also have, interesting feature. Anyway, we have an energy efficiency network with people who specifically look at energy efficiency from a developer's point of view. Here you see the representatives who are working currently on specific projects which should make, like energy efficient game development easier for you. So one of these projects is like energy measurement in the backend of engines. Another one is mid-game power measurement on PC and console on the based on the example of goals. And another one is the energy saving plugins. Like you will hear today about the Unity one, but we also have this power saving plugins for Unreal and Godot. Okay, and now I would like to say a few more words about the speakers today. So we have Oliver Stock, who is an indie game developer and founder of Walk the Frog, a studio based in Ludwigsburg. And he is not only passionate about game development, but also about the environment. So that's why when he first saw the Unreal power saving plugin being developed, he reached out to us and was like, I need to do the same for Unity. And I'm really grateful about that. And that's what you will hear about, just in a few seconds, basically. And then we have David Zapfe-Wildemann. So he actually wrote a bachelor thesis on the topic of energy efficiency and Unity and game development, and put like all his learnings into practice within the Tiny Bookstore. But more on that, of course, also from David. We also have with us Neil Patel from Take-Two Interactive. He will be able to basically give his insights from a sustainability point of view, because it's sometimes quite hard to connect these two topics, development and environment or sustainability. So we have a real expert here with us. Neil has a lot of experience in sustainability reporting, ESG, and of course, being at Take-Two with game development and all around that. And last but not least, Dale Kim, who is a software engineer at Unity. He also actually gave us some inputs in our last meetup, which I really highly recommend you to check out. So he will be supporting us from his point of view because he helps with performance and scalability of Unity's job system. So yeah, highly knowledgeable on that topic. That was it from my side. I will now hand over to Oliver. Thank you everyone for joining us. Wait, droop. Yep.
All right, you should be able to see my presentation. So hello, my name is Oliver Stock. As Maria already said, I'm a game developer and co-founder of Walk the Frog and also the developer of the Unity Energy Saver plugin. But before we talk about the plugin, first some attributions are in order because plenty of concepts that I use for my plugin come from other places. So my main contribution was picking up what's already there and combining it to a Unity plugin. So there's already a great document reducing Fortnite's power consumption released by Epic Games. Hauke Thiessen, the author of the Unreal Energy Saving plugin. And there was also a blog post by Bronson's Gap. And basically I took that and decided what's the best fit for Unity and then developed it. In the next 15 minutes, we will talk about the core ideas behind the plugin, the architecture and how it works, what's the use with some charts. I did a little bit of monitoring to see what actually gets saved in terms of energy and energy consumption, and then some conclusions and future plans. This is the Git repository. You can download it immediately. It's been online for 2 months, I think. And the idea is that game performance and saving energy can be very technical, but the goal is to make it more approachable and more easy because it does not all of the time have to be very technical. So the plugin strives to be easy to use, it's flexible and easy to extend. It works with the legacy input system and the new input package with the universal render pipeline and the high definition render pipeline. I have tested it with Unity 2022 onwards. It might be compatible with older Unity versions, but that needs to be tested by you. Yeah, it's open source. You can download it via Git or the package manager. It's still early in development because in 2 weeks we are releasing our game. So unfortunately, right now I don't have that much spare time to put into it, but afterwards it will go up higher in the priority. And yeah, I would be happy for any feedback, especially in terms of usability. As a developer, do you want some features that are missing, or do you find it easy to use, or are some things not intuitively useful? That would be very nice for me to understand so I can improve it. This is the main question the plugin is asking. Is the user active or not? Because optimally, we want to deliver the best gaming experience while the user is playing. But as soon as they start to idle or in some other contexts, we can save energy and should do so. So this is the question where the plugin starts. When there is user input, nothing changes. Everything is as you know it. It's the same. But as soon as the user stops inputting for a certain amount of time, then we start a timer in the background and we evaluate some power constraints that I will talk about in a minute. And then we will select an energy profile, as they are called, which is basically a recipe of in which areas could we save energy and what is the best fit for the current situation. The architecture is as follows. We have one energy saver script, which is the big brain, a singleton. You put it in your scene as a prefab or in some other way, and then it lives there in the background of your game and communicates constantly with another script called Power State Controller, which is basically a class that evaluates at the moment, what energy profile do we need? Are we idle? Are we playing? How long have we been idle? Do we maybe even stop rendering completely because the player has been gone away for, I don't know, 10 minutes or so? So it tries to find out what's the best fit for the current situation. And then returns an energy profile to our energy saver. The energy saver then takes that profile and applies it to various I-energy actions, as I've called them. That's basically an interface that affects performance. So to recap, we have a game object in our scene with one energy saver script on it. The energy saver has an own class called Power State Controller, which it's constantly talking to. And then on the game object energy saver, there are different classes that derive from iEnergy action. And I have 4 already in the GitHub repository, but this is a avenue that you could take to maybe write additional energy actions that fit more better to your game, because my plugin strives to be very a fit for all games, but as you know, some games have special features that you might be interested in saving energy that are not applicable to other areas as well. And the energy profile is a scriptable object, so you can tweak yourself what the different energy profiles are, what states you want to catch, and how long it takes for them to apply, that kind of stuff. So you decide which situation, which profile gets applied. And this is how it looks in Unity. Basically, what I described earlier, you have the energy saver, and in the editor, you get visualized which profile is currently active. Here, I was not playing, so no profile was active. And we have an input source, which basically is just listening to any kind of input. Is there input happening, yes or no? And in the lower half, we have these frame rate action, rendering interval action, render scale action. Those are those iEnergy action derived classes that I was talking about. So basically, you can decide which type of energy action gets applied in your project, because maybe you do not feel comfortable with applying all of them and only want a certain amount or a certain type of them because they fit your game better or not. And this is what an energy profile definition looks like. As you can see, it has 2 groups of data. In the upper row, you have activation after idle, so how long does it take for the profile to kick in? Then you have power constraints. Those are, is the device plugged in or is it running on battery? Is the game in focus? Is it not in focus? Because those are, of course, important in evaluating how much power the game actually needs to run. Because if it's not in focus, then maybe we can save a lot more energy. But if it is in focus and it's running on battery, yeah, those are different cases, and you can yourself decide what's the best fit for your project. Then we have an FPS cap, a render interval, which is a Unity feature, which allows you to skip rendering for a certain amount of frames, a render scale multiplier, and the physics simulation mode that you want to use. There's another example. In the first example, the activation after idle was 0, so the profile would kick in immediately if the game was running on battery. And this one does kick in after 30 seconds, but has no power constraint, so it does not care, is the battery charging or decharging, is the game in focus or not. This profile does not care about this, it only cares for how long the player has been idle. So this means 30 seconds of no input at all, no keystroke, no mouse movement, nothing. Then this profile becomes active, and it's very aggressive. It caps FPS at 5, and the render interval is set to 10, so that means a new frame is rendered every 2 seconds. And the render scale is set to 25%, so the game resolution will drop noticeably, and you will see that too. But as soon as you move your mouse, then the constraint activation after idle is no longer true, and you immediately come back to full speed, and the player can have the experience they want with the game immediately. Yeah. And those definitions are scriptable objects, but you are able to override them. So the energy profile definitions contain a class energy profile, which is the class that is actually being read by the energy saver. So you might also want to allow the players to override that number. Let's say you have a cozy puzzle game, and 30 seconds might just be too fast for the profile to kick in. Then you could allow the player to maybe change that in the settings, that they can say themselves, I'm a bit of a slower player, maybe I need 60 seconds or 90 seconds before the power saving kicks in, because this makes me feel pressured to move my mouse or anything, which you might not want. So you have the possibility with the current architecture to expose some of those settings and then save them in a JSON file or whatever and combine them in your energy saver, so the user has the experience they want when they are playing your game. Yeah, just to recap, as you can see, here in this case, there are 3 energy saving actions on the game object: the frame rate action, the rendering interval action, and the render scale action. But if you can remember, here we have also the physics simulation action. This one is missing in this case. So since they are interfaces, you can decide for your own which component you want to add to the game object. And if one is missing, then the data will not be applied in the energy saver, it will just be ignored. Because, for example, your game might be reliant on physics to update all the time. So yeah, then you can exclude this in the profile. It's up to you which energy saving actions you want to use or not. So then what's the actual use of the plugin? For this, I bought this tiny tool here and played our current prototype of Walk the Frog, or our game that will be coming up in 2 weeks, and basically measured the watts. I did 10 data points. One time I was exporting the game without the energy saving plugin, and another time I had the power saving plugin running. And every 3 to 5 minutes, I just took a quick glance at the power measurement and was checking out how much energy was being spent. The energy fluctuates a bit, so this is to be expected. So you should probably, if you want a very clear-cut image of your game, you should probably do a little bit of more measuring, but this is just to get a rough idea and a rough grip of what's happening actually in terms of electricity. So this is the first graph of the game running without the energy saving plugin. So just the game as you would expect it, without any additional energy saving features. So all the optimization was done in engine, but without the plugin. I took 100 watts as a baseline because this is what my Windows 11 machine was using when nothing was running at all. So you can see at the 100 watt line is basically the zero line, so to say, and then those 10 measurements are taken within 30 to 40 minutes of gameplay. And then we add a second line. This is with the energy saving plugin active, but I wanted to test something. So in this case, VSync was turned off. And you can see two things immediately. At first, the second data point where there's a small gap or a valley is when the energy profile was kicking in because I was not giving any inputs. And all the other data points are with me actively playing the game. So you can see when there is no input, the valley is quite deep. There's a definitive visible drop in energy spent. But what you can also see is that when I'm playing, I actually use up more energy, and we will talk about that later. And the second pass was me also using my energy saving plugin, but with VSync turned on. And there you can see in the second to last data point was when I was idling. There is a valley again. So you can definitely tell when I'm playing, the gameplay experience is as you would expect it, nothing is changing. But as soon as you start idling for an extended amount of time, I think in my case it was 1 minute of idle time, then the first energy profile starts kicking in. Then we see a drop in energy spent and energy consumption. What I found interesting about this is that I realized that my mental model was wrong. I said one time I was turning VSync off, one time I was turning VSync on, because my mental model was the lower the amount of frames I'm rendering, the better. And Unity has a feature application.target frame rate, which only applies when you have VSync turned off. So if you want to cap frame rate at 60, you need to turn VSync off and then use application.target frame rate. And I thought this was an avenue to go, or to try out at least. But what I found out is that modern architecture, modern computers have plenty of abstraction layers and optimizations already built in. So things might not be as easy as you first think. In this case, putting a hard cap on the frame limit reduced the frame time, that the amount of frames being rendered, but caused so many synchronization issues that it's resulted in the orange line, which was actually less optimal during gameplay and only was saving energy when I was going idle. And then when I turned VSync back on, then I had the advantages of both, of the modern architecture, but also of the energy saving plugin. So, and this, of course, for me, underscored the importance of measuring, because you can see in the Unity editor how many frames are being rendered, but that does not necessarily translate to what's happening actually in your computer. So you can be smart and have a good working mental model, but in any case, the best thing is just to measure it. Use the profiler, use hardware that actually tells you what's really happening and not what you think might be happening. Yep, so you can observe with a minimum amount of energy spent, that with the energy saving plugin with VSync turned on, you had a definite decrease in energy spent, both in the minimum as well as in the average. In the average, it was not as high, but probably also because Walk the Frog, as you have seen, is very simple in terms of what's actually being rendered. So it's a couple of 3D meshes that have the 3D nodes and also a couple of sprites. So it's not comparable to other games that have more action going on. Yep. And a fun fact, when I did a little bit of debugging and worked on my game in Linux, when I had Unity open and was running Linux, I used 92 watts instead of Windows 11, which ran on 100 watts. So in terms of energy saving, you might consider switching to Linux because the operating system is more performant on its own. So that might be a consideration as well if Linux is on the table for you. Now we're coming to conclusions and future plans. Conclusions is slight energy saving with the plugin and VSync turned on is possible, and the longer the idle duration, the higher the saving. Of course, you want your players to be playing, but sometimes they grab a cup of water or whatever, and then their energy can be saved. But also, I would love to integrate game states such as in menu or loading screen or in cinematic, because in a cinematic, you do not want power saving features, and they might be longer than 1 minute or whatever you set your power constraint settings to. So these are things I would love to add in the future to give you more control and to always make sure that energy is saved where it's possible in loading screens, in menus, but cinematics do not suffer from your choice to use the plugin. You can already lock the plugin, so it does not start saving energy, but this might be tedious to lock it and then have the cinematic and then unlock it. So it would be better to just have a possibility to say it, now a cinematic is running until this event is happening, and then everything goes back to normal. And I set myself the goal to add those features and an improved workflow until Gamescom. So when we meet there, then you can all hold me accountable for that. Looking forward to that. And then the second to last slide is, you probably all know it, but that's a little bit of a departure. We're currently living in an ecological polycrisis. Animals are dying in a rate comparable to the events that wiped out the dinosaurs. We're living in the 6th mass extinction, and there's also the climate crisis going on. So there are several ecological crises. I think the plugin is neat, but of course we would need to push for an industry-wide change on an international level, on a national level, on an individual level. That was just another thing I wanted to add because it's important. We are stretching the Earth beyond its capabilities. That's it. We'll continue with David Zapfe-Wildemann and how energy efficiency best practices were applied in Tiny Bookshop.
Thank you. Thank you, Oliver. I quickly wanted to add, so actually there was like a case, like a study done by Microsoft, and players, especially on PC and console, spend around 25% of their play time in idle state. So yeah, there is a lot of energy we can save with that. Yeah, and now David.
Nice. Thank you. Can you see me and hear me all right? Do you see my screen? Is everything working?
Yes. Yeah.
Awesome. Okay, hi everyone. I'm David Zapfe-Wildemann. I'm a game designer. I'm a game developer. We recently shipped our game Tiny Bookshop. Recently, it's August last year, but we're still on it, and it feels like it was yesterday. Before we made this game, I actually researched the environmental impact of game consumption as my bachelor thesis. I also came across this lovely table here by Ökopol TU Vienna, and I've highlighted here the interesting bit that games make up a large part of the emissions of game hardware. Like actually playing the games using the hardware is responsible for a large share of their greenhouse gas emissions and the resulting waste. So that led me down the avenue of like trying to figure out, can we design this? Can we negotiate this? Here again, I try to calculate based on some other studies, like how much of the US electricity at the time, that was 2019. No, that was 2022-ish, so around the cryptocurrency boom era, like was actually devoted to games. It's a significant factor. It's not like nothing. It's like 0.8% of the US electricity at the time. Now with the 8 data centers, who knows where that share is, but it used to be significant. Yeah. So I made a little experiment, I think similar to you, Oliver. I've wanted to figure out like how to measure this. So I took, you can see it here, the blue thing in the middle. That's an energy meter that you usually put into buildings. The nice thing is that it's like it's genormed. It's it's geeicht, we say in German. So it's like legally, it has to be has a certain precision, which is nice because as a student I couldn't afford like a precise measuring instrument. But this is like legally it has to be precise enough to be used in buildings. So I wired it up to an Arduino to count like the pings it sends out, and then I could log the data in the Arduino. I designed a little experiment in Unity at the time, and that gave me this nice chart here. Top one, going back here, you can see resolution, iterations, like I had an algorithm that did some math and some lights to try and balance the load on the GPU, CPU. And you can see here that there's a correlation between how complicated, so left to right is how complicated the calculations are, and the three colors, they are with different frame rate caps. So you can see on this device, for instance, the difference is usually much bigger between the like between the frame rate cap than it is between the complexity of the stuff being done, because I was not able to, yeah, reach a point where it's still like it would approach it here. Like there was still like headroom, basically performance headroom. So capping the frame rate always helped. So that led me to this silly little model here that I use when I think about how to optimize my games. And that is we have two levers basically. We have how complicated, how resource demanding a code is, and where we cap the frame rate, how we cap the frequency at which it runs, right? And so we took this model basically, and we I kind of incorporated it into the way I wanted to design my game. And these are the two main levers I have basically to negotiate the game consumption. Which you mentioned it briefly earlier, right? Like there's these, we have the how much power it draws and how long for it draws that power. So if we spend 25% of our playtime idling and getting water, that's like a higher duration, and it's also we can like reduce the duration of that maybe, or we can reduce the power it draws during that time, which is an interesting thing to think about, because then you can think about how much time are my players spending in matchmaking, how long are they spending in character selection, and how demanding do these places get to be compared to the main core of the game. So this is all like, again, like the prerequisite to Tiny Bookshop, but here was my plan for our game. We have the game phase of absence. The player is gone, so we detect that and we stop rendering the game. Then we have passive elements of non-play. These are like the menus or the escape menu, right? Or the settings screen, like these. Oh no, these are loading screens. These are loading screens. So you have the loading screens. We pause 3D rendering in loading screens. That speeds them up a little bit, but it also means the GPU does nothing while things load, which frees up some power consumption. Active elements of non-play. These are your menus. This is like the escape screen settings. We stop 3D rendering the game. So you're only adjusting like the UI basically. Then we have passive elements of play. So this is you lean back and are gone maybe. We pause 3D rendering, or in general we introduce an FPS cap and optimizations because frame rate isn't super important. And we have the active elements of play. This is where response times kind of matter, where you want to like you're moving the camera and stuff, but still we enforce a frame rates cap in the game. The game can never run faster than your screen can output it. So it's either with VSync or with the frame rate cap. That's your choice as a player, but you cannot set the game to have unlimited frames per second. Yeah, and then there's like a little bonus round for the device, right? Like in the example I showed earlier, that was a Windows 10 PC. So interesting that for Oliver, for you, the Windows 11 PC is like at 100 watt now, whereas that Windows 10 PC was like at 50 watts at idle. Crazy. The Switch, for instance, it's like at 8 watts on idle. Like it's good to just support the Switch if you release a game, because it's like it's the most efficient gaming PC there is. Still, like maybe a phone as well, but these things matter just as much as like how we design the game software, like what devices we support. The same also for me goes for I want to support a wide game ecosystem and I don't want to force players to upgrade their hardware constantly. So we bought like the oldest PCs we could reasonably support, and we also installed Ubuntu on one of them to make sure like players have options when they want to play our game. Yeah. So let's get to some concrete interventions. Like you, Oliver, we ended up with having a timeout detector. We have two states basically that the game can have. We call it long and very long. For us, it's 2 minutes and 5 minutes. And then you can see an example here. So you see the game renders here. It's the map screen. Probably a place where you might go and, I don't know, make yourself a coffee or something because there's no real-time interaction happening. But if you could see it here at the end, the game actually secretly stopped rendering. Like the players won't notice, but you can see here the waves stopped moving, the clouds stopped moving, so the game actually stopped rendering. And our goal with this is that players don't think the game is broken, because a lot of people play our game, and we don't want to get a lot of like bug reports being like, "Hey, my game sometimes stops rendering, whatever." Or we don't want streamers like on stream chatting to their community, and then suddenly the game visibly crashes or something. But this is like a good compromise for us to be like, okay, if you're gone for X minutes, the game will stop rendering until you come back. The same goes, we have a setting for if you alt tab out of the game for it to stop running. That's like a Unity default. You can enable that or disable that. But enabling that again kind of makes the game seem like it's bugged for streamers. So I advise against having that as the default because streamers tend to tap out of the game into their streaming platform, and then you have people that on the stream, lots of people think your game is broken, and that's not nice. But it's a setting that players can opt into if they want to. It's called application run in background. Yeah, then for mobile platforms with smaller screens, we snuck this one in. So as soon as you open a UI in our game, uh, this one is very full screen anyway, but pay attention to the waves and the clouds, they stop moving again. Like the game, the entire 3D scene of the game stops rendering, and we profit from having the game run into render textures, so we can just keep the render texture around with all that data. And that really frees up a lot of performance that we're then trimming off, right? We have the frame rate cap, so as soon as there's headroom for the game to run faster, we just say no. We give the GPU and CPU some idle time. Yeah, then we support a whole bunch of settings. For instance, 3D resolution scaling. So even if you run this game on an integrated GPU of a 2015 notebook, you can figure out a setting to make this game work for you. And we also detect the settings for you on startup. And we choose the settings that allow the game to run at the highest supported frame rate that your monitor supports. So if the game, yeah, so we optimize the settings for you, so you have good defaults. But then, yeah, and here you can see with VSync a target frame rate, you only get the choice between having VSync on or off, but you're never able to increase the frame rate above whatever the monitor you have supports. Yeah, so we kind of forced the players to do that, but no player ever complained about this. Like we thought, okay, there might be the CSGO players that want to run this at 800 FPS, or the hardware, the hardware buffs that want to test how Tiny Bookshop maxes out their 3070. I'm sorry, Tiny Bookshop will not max out your 3070. Yeah, we developed it on like 960 and 1060 GPUs, and I developed it on an integrated GPU. Like it's fine. Yeah, again, we support many different devices. This is actually the shitty laptop we call it that we bought. It's like an older HP laptop with an integrated Intel GPU. So it was a nightmare to get the game running well on it, but we try to make it work. We have the same spec Linux PC as well to make sure it runs well on it. Yeah, so this brings me to my outlooks. Kind of the defaults really matter. In the beginning, we were much more aggressive with the default settings, but then during the demo phase, streamers played the game and they were like, "Oh, this game stops running when I tap out." We adjusted it so the energy saving stuff is where the players don't think it's broken. Kind of. That's the balance we have. Um, every device is very different, so we didn't really bother measuring the impacts. We should probably. I think it would be very interesting to try it out on a couple devices. Um, yeah, and if it works, players don't tend to notice that there is energy saving stuff happening. Like we explain it in the settings that you can turn or increase or lower some graphics settings, for instance. But players, like we had no player call out, oh cool, the game has energy saving stuff enabled. Like no one ever noticed, no one cared. And it is extra work. Like it took us a while to like support the different resolution scaling. It took us a while to figure out a good way to pause the rendering so it's graceful and players don't think it's broken. Like all of these things take testing, they take work, but I think it's worth it. Yeah, if you have questions or ideas now or later, you can email me or we can talk. Thank you.
Awesome. Thank you. Thank you so much. Yeah, now Neil, maybe you can take over now.
Hey,
Thank
thank
you.
you. Thank you, Oliver and David. That was really helpful breaking down kind of how you used it specifically. David, just on your last point, you mentioned how users have the option to opt out. Are you able to track how many players opt in or opt out of it
No, we don't track
of
any
the
user
settings?
data. We're very German about that. No, no user data, nothing. I don't want to have your data.
Nothing like that. Oh, that's unfortunate, but yeah, it makes sense, and I think that's a challenge that the industry faces in terms of, not only capturing the energy savings, but also feedback on this. So if they're not vocal about it, it's hard to understand where it actually lands. And so that makes sense.
Yeah, but for us, they're not able to opt out of like the frame rate cap or anything. They can only adjust the quality settings of the application.
Actually,
Okay.
there was a case study with For Honor, and they introduced an eco mode, and then 80% of their players just kept it on. So if you don't say it, no one notices usually. So yeah.
Okay. Yeah, if they're not noticing it. All right. And then I think a lot of folks will understand as they report into management and such, there might be a lot of hesitation around incorporating some of these efficiencies at the risk of player experience. How would you guide or how would you encourage these developers in terms of talking to management or senior level teams that aren't technical?
Phew, that's difficult. I didn't have to convince management because I'm indie and I am the management, right?
Yeah.
So that's
Well, that's a good first step, I guess.
yeah. But I think, yeah, it's like Dale, right? Like last time you talked about SIMD and to using that. I think as developers across all disciplines, we want our games to run smoother and be performant. And then saying, okay, we have these gains, and then we kind of offer the option to trim them off or make that the default. I think that's already a huge win, and most players will not notice or will be bothered by it. And that's not very difficult. Like the smaller gains, like detecting when someone is AFK, like that stuff takes a bit more work, but you're naturally optimizing your game to run on more devices. And then passing these things on to the energy bill of players, I think that's a pretty easy step.
Yeah, and I wanted to add, I think it's pretty important to be able to concretely explain to people what the players are going to get. And a lot of people, they kind of think, ooh, you're going to spend all this effort to like do this energy saving feature instead of like fixing a bug in the game, right? But I think it actually affects the player experience quite a lot. There's a lot of times I'll be playing like a PS4 or PS5 game, and all of a sudden I can hear all the fans spin up. That's not awesome, right? Battery life goes down. People can play for a shorter period of time. So like I think there's always a way to kind of like say, hey, if we do this, more players will be able to play longer. Or maybe David, like you were saying, you got a really old laptop. Sometimes it's a matter of, well, it's also increasing platform reach, because we're trying to make it work on a less capable device for energy savings. We can still get like maybe more people will buy and play the game because now they have more devices to be able to play it on. So I think doing it in that lens is sort of like the most effective way to try to convince other people, like this is worth doing.
I think the platform angle is one of the strongest arguments because lots of games already are being developed, and the plan is to ship them maybe on mobile, maybe on a handheld console. And you can always give the argument, the effort we put in now to save energy will return as an investment as soon as we start developing for platforms that are not plugged in all the time, that don't have such a strong CPU, GPU as a desktop PC might have. So yeah, that's what I would say.
I mean, actually, also like if you have like Steam Deck and you are traveling by train, I have some friends doing that. They have like just games which they play when they travel because other games will, yeah, it's just not possible. So yeah.
Yeah, it'd be great if there could be a label that says train friendly games. That we know, are energy efficient, they can last longer.
That's a fun idea.
Similar, kind of go with that. A lot of the handheld or laptops, they have energy saving modes already, like iOS. How does this interact with that, if it does, or anything like that that we need to be aware of?
Oliver, does your plugin have a way to detect if the user requests an energy saving mode?
Unfortunately not. When you were talking about the extra round with the devices, I was like, yep, that's on the to-do list too, but later on down the line. Yeah, do you have experience in like checking out what operating system is running? Is it with the battery or not? Because one of the first things I found out that there is no reliable way for Unity to tell, is this actually a machine running with a battery or not? You can only check for the battery status, but you cannot check has battery or if it's just plugged in to the wall. Yeah, so there are some engine level problems, but have you found out ways to, or what are you doing for Switch mobile?
So for Switch and Steam Deck, there's like you can use the API to know if it's a Switch or if it's a Steam Deck. Like that stuff is relatively straightforward. For mobile, if we were to look into mobile, we would probably go a similar route to see if it is compiled for iOS or if it is compiled for Android, and then we add certain settings. And sure, there's gonna be a Chromebook or something, right, that runs Android now, but these still use battery, and I've not heard of many fully plugged-in devices that don't have a battery running these operating systems.
Yeah, and I think the other thing I'm going to add here is a lot of these things are like operating system, like it lives at the operating system level, and often the app isn't even aware. Like the operating system just changes its behavior. So it might be a thing where we don't actually know what's going on, at least from the Unity side, but I'd have to check. I suspect that there is very little interaction directly with these power saving features on these systems, though.
Some phones also turn them off as soon as you enter a game, right? Like there's
Oh,
game
right.
mode, and then they
Right.
they give the game more system resources again or more GPU time.
Yeah. Oh, that's interesting. Yeah. All right. So Dale, I don't know if you have any questions on this. I have one on workflow and kind of team settings.
I did have one question. It was regarding just the overall process of improving, like for energy efficiency. Did you guys have to find that you had to really plan for it at the beginning, or is it something that you can kind of just kind of do at the end as you find necessary? Like, have you tried both? Do you know which one is better, if one is better?
So for
Oh,
us, we had the philosophy to don't get overpowered development PCs and to keep testing on normal devices regularly, frequently, because if you have to fix everything at the end, like that's gonna be a nightmare. So we regularly because there's such a long parallel path for improving performance and improving energy efficiency. Like these really only diverge at the point where you cap the gains of the performance energy efficiency, right? Like you wanna take them home and cap the frame rate or the frequency with which things run on. So for us, it was from the beginning we said, okay, we test the game on the shitty laptop once a month. Our development PCs are used PCs, and we tested on them regularly. Like that really forced us to stay with the players side of things. If that makes sense.
For me, it was also regularly checking in, and also sometimes when you have to make decisions. For example, for us, it was I have 2D sprites on 3D meshes. I want the sprites always to be in front of it. The easy solution would be just use a second camera. One camera renders 3D world, the other renders 2D sprites. One is always in front of the other. And those are the moments where you know, okay, I can do this. That's the easy solution, but there probably is a better solution with one camera that's a little bit more work. So when you develop games and know a little bit about the engine, you can get a feeling about which questions can drastically improve performance or not. I'm probably not the biggest expert in that, but that was one thing where I was like, no, I can do this with one camera, and I should try to get a better developer and do it with one camera instead of just like doing camera stacking or whatever. And then other things are just considerations you do on a regular basis. For our game, we have those post-it notes. They are all square. So the immediate thought was to use a sprite atlas, but then I was like, they are texture arrays. Why would I not use them? They are basically exactly what this game was made for. And I think this was, in our case, an opportunity for us to save a lot of draw calls, because basically all our 3D objects use one or two materials only, because they just use one big texture array where all the textures are being stored. So for us, it was like new features are being added or things are changing, always with the question, is this impacting performance or not? And if so, in a major way, and how can I alleviate that, is what I would say.
Awesome.
Right.
Thanks.
And I guess similarly, so you guys are testing it on a broad range of hardware and that aspect. Are there category or game types that are more of a natural fit for to be optimized this way as well? Or games that are, like don't make sense at all?
Oh, so for us, having a management game, I think they're a natural fit for a frame rate reduction optimization. Because players like it doesn't they don't tend to be like super players don't tend to be all about the millisecond delay between input and response. I think like fighting games or first person shooters might be less forgiving with that type of optimization, but I haven't made one of those yet. I'll I'll update you once I've tried.
I would slightly reframe the question and not ask what kind of game we're playing, but more like, how does the game look like when we're in a menu? Because I could see us playing an MMORPG like World of Warcraft. What happens when I hit the escape button to open the menu? Do we have the opportunity, like in Tiny Bookstore, to just stop rendering completely? And is it a huge gain? Because modern games sometimes just have a blurry overlay, which adds performance cost because you have to render the screen twice to blur it once. And then in the back of the menu, everything is rendering with maximum depth of field unnecessarily. So I would say the question is more like, what do the menu screens look like? Ironically, because I would say when you're playing, of course, you want to optimize the game's performance, but you also want to deliver the best performance a player can have. But you have to identify the moments where you can save, and these are the menus, the loading screens, or maybe even a cinematic where you can maybe disable half the game world because you're not looking at it. So my answer would be, it's not a question of genre, but more like, what is the menuing experience of your game, so to say.
I just quickly dropped a link to our energy efficiency guide because there is a case study of Halo where they specifically worked on like menu and yeah, did that. So
Okay. Um, no, I think this is really helpful. And one thing I wanted to understand, as you guys are working part of your teams and the workflow, how do you share this information with, the distinct teams that are doing QA and are testing it so they know that this is an intentional drop in frames and things like that versus a bug?
I think that question goes to you, David, because we are two people. For me, it's I shoot a message on Discord and then we are done.
Yeah, for us it's probably similar. We're now 8 people. Um, but yeah, I don't think anyone. Sometimes I sneak these things in and no one notices, and then I know I've done it well. You know, like not everyone needs to know that these things are in, but when it comes to settings and communicating the need for them, I'm always very open. I'm like, hey, I want this, I want to add this setting. I know it's more work, but one, it makes the game more accessible to players with worse hardware, and it makes the game more energy efficient and these things. And then usually the team is very, yeah, let's do it. Yeah. But it's yeah, as an indie studio, like the travel paths for these messages are so short. Like we only have to convince one other person and then we're golden, right? I imagine that that's much harder for a bigger company.
Well, I actually did want to add on to that question. Do you guys have like debug views of the current state of, what you're doing for the energy efficiency? Because, it's really awesome when you can deliver it and most people don't notice, right? But as a developer, you kind of need to know when this is happening. So surely you have something built up to help you determine what the states are and determine when it's wrong, right? What kind of tooling do you guys have?
That's something I'm also interested in, but currently I only have which energy profile is being selected and my power meter, but that's something I also want to add in the future as some kind of window where you can also anticipate will a switch of the profile be happening in the near future because they've been idle for however many seconds. But that's also one thing I would love feedback to actually, because I think in terms of developer experience, that's the most important step to always at a quick glance get where you're at with energy saving and what avenues it might go down to. But right now it's only one little editor icon saying which power profile is currently being used.
Yeah, it would be great if engines would add such a feature. Sorry, I just wanted to say that. Yeah.
Yeah, for us, it's like we don't have distinct states that the game can be in, right? We have smaller systems with smaller tweaks, like the timeout detection. But I'd say for us, the biggest tool is the Unity profiler. Like, because we want to make the game run theoretically faster, and then we just cut it off. We often just measure the performance impact in the profiler, and then yeah, see if we actually reduce the demand on the hardware that way.
I would also have two quick questions for you, David, if nobody else has an important question. And the first one is in the Godot plugin, I think they said that Godot offers the feature to dim the monitor. Is that something you've explored as well? Just like putting a black texture over the screen with a certain opacity to just reduce brightness and also reduce power consumption that way?
That's an interesting thought. I think we talked about it, but yeah, that makes the most sense for monitors with local dimming or OLED monitors. And for other people, it again might look broken. So we were weary of adding that without knowing, like, if players are aware that this is a thing or not.
I get it. Because I thought if maybe a player is stepping away from the game for 10 minutes or so, you might not lose anything. And I'm also considering doing something similar because I feel it's relatively well known that screens can go darker and brighter again when the need is there. And
Mm.
what was the second question? I forgot. Yeah, I'll ask it another time.
Yeah, do that.
Okay, anyone else a question? We don't have to push it if there are none. But anyone, questions?
I have a question.
Yeah.
I have a question about maybe it's for Dave because it's on the engine side, or also for Oliver if he explored some of these paths. If there is a way to measure the energy consumption without having to rely on an external tool, but on the operating system level, maybe Windows or I don't know, Linux have some sort of measurements. I guess the laptops, they know when the battery is used and how much power uses the battery. So I guess the motherboard or some system has to know how much power is drawn, and if that could be inserted into maybe the profiler or a tool like Oliver's.
I think for mobile, there definitely are Unity features already out. I forgot the name, but there is a maybe Tommy, can you remind me of what the name is for the advanced profiling for mobile, if you have a mic on hand.
Yeah, do you hear me? Yeah.
Yes.
Adaptive performance, right?
Yeah. So the adaptive performance profile is already a great resource because if I recall, you can record thermal stats and other things, but I'm not sure if this is already in place for a desktop PC.
So regarding that question, the situation is actually a little complicated. On most mobile devices, unfortunately, you can't measure power directly. It's almost always some sort of estimate that the system gives. The estimates vary. Sometimes it's okay, sometimes it's wildly inaccurate. So, depending on that, it's actually really difficult, unfortunately. And on like desktop, it's actually even worse because there's just no hardware to actually measure the power. You can measure voltages and things like that, but doesn't really tell you exactly how much power you're using. So the situation is unfortunately not as much data as we would want. Um, I think there are conversations going on at various companies to change the situation, but I'm not sure where we're at. But today, it's actually very difficult to get like power measurements directly. So it's all inferred by some other measurement.
Thanks for the answers.
Maybe that's a part where I can also tune in, because the last few days I spent developing like a optimal pipeline for answering that question on Android. And right now my primary source there is the battery manager API, which again is a like estimation, but I defined like a default on what should be turned off, like basic Wi-Fi, Bluetooth, etc., all that stuff, and which hertz it should run on. And with that, my measurements got a lot more precise and comparable, actually, to like 5 to 6 milliamperes. So yeah, I'm on that. Maybe in the future I can deliver more on that. But yeah, that's my state with that.
Awesome. I mean, so we only have 1 minute. I would like to use the 1 minute to thank again all the participants and all the speakers. And yeah, if you want to know more about energy efficiency and game development, please visit our website. We have this kind of meetups coming up all the time. The next one will be on the 26th of May. And we will be discussing a case study by Saibo. Yeah, you will see more information and can register for that on our website. Yeah, thank you everyone, very much everyone. Have a good one.
Nice. See you all.
Thank you all.